uh, everything's a complete mess. But I just got out of the shower, where all good ideas happen, as everybody knows, and I was thinking about a lot of conversations I've been having lately with people who are not very old. They don't have very much experience. And so they say interesting things like, well, you can train anybody to code. And I'm like, what? I'd fire 90% of all the developers developing today. They suck at coding. I don't know what you're talking about. I've run training courses, I've mentored people, I've done all that. And sure, there's a lot of value in that if you have the aptitude, but most people don't have the aptitude. It doesn't mean you can't find a place for them. Look, variables and recursion, that's a lot of code. It's a lot of code. But if you're going to use a variables and recursion coder, which, you should, I mean, you have to, right? You're not getting around that. You got to set things up for them. They ain't writing algorithms. That's for sure. Right? And if you try to make them, they'll write garbage. And this sort of extends through the stack. So, a recent conversation with somebody who insisted that, anybody could learn, things like Docker, right? And I had that conversation again, 2 weeks later, and I'm like, the Docker commands, sure. But what Docker is and how to use it without creating problems, no. And so this goes back to, and I wish I had an animator full time because that would be glorious. There's a right way to do this. There is. We know what it is. We've had very stable software in the past. So we don't have it anymore. Just ended, I think, I hope, a 2-month cycle of 20 updates every 2 days, or at least twice a week for 2 months on, I don't know, do I have 120 or 150 apps on my phone? I don't know. Some of those are in deep sleep, so those aren't getting updated. That's a lot of updates, guys. That's a hell of a lot of. I haven't seen any functionality change. I've seen more bugs. I've seen more things just kind of do weird things, and I was like, oh, whatever. I don't have time for this. I'm not here to debug your freaking Android app. But that's a lot of updates, and I don't see a change. What's going on? It could be legit, some of them, right? And this idea, like, I had to explain to somebody, they're like, oh, yeah, you got to get it out quick so the customers can, give you feedback. And I'm like, yeah, but in the old days, the customer was just happy. I never had to give us feedback other than this is awesome. We love it. I don't know why that isn't better, but to you, inconveniencing the customers with bugs is better. Okay, man, like if that's your jam, but there is a right way to do this. And when you remove that right way, so you have a process, and that process is, it's not really 80-20. It never was 80% architecture, 20% coding. That never happened, right? But whatever. When the process is architect first and then start coding, you don't need cybersecurity. It's not necessary. It's just extra. Why? Because the process of securing the application is taken care of by the architecture. And a lot of people make a lot of hay out of, memory leaks and bugs that cause, execution access above the execution access level. But all that is legit. But I will tell you something. If you actually look at break-ins, the overwhelming majority of break-ins are software misconfiguration errors. Say it with me. Software misconfiguration errors. Typically in code the company didn't write. In other words, we set up AWS wrong. Okay, how's a software engineer supposed to know A, how to set up AWS at all, and how to do it right, and what the implications are for the software? Because it turns out that the real conflict is when you do the so-called cultural DevOps garbage, complete and utter garbage. What happens is the software engineers jam down the throats of the DevOps engineers insecure architectures and configurations, and then somebody breaks in. I've told this story before. This happened to me at a large cell phone company. It didn't happen to me. It wasn't my group. I didn't care. But they built a store like the Google Places way early days, right? They built a Google Play Store equivalent, right? They were going to compete. They had their Play Store. It was up for a month or so. The machine had been broken into. The DevOps team, because I was part of a DevOps team, just not that one. They had lots of groups in this company. It's a big company. The DevOps team had lost the battle, right? And the battle was, we want to put your machine and the software into the production environment. So they lost that battle. They let the software engineers do it. Software engineers put a machine in place, and I don't. Every time I think about this, much less tell the story, I'm just so overwhelmed with the amount of stupidity involved. It's hard to imagine. The machine had SSH installed. Problem number one, right? It had, so the developers configured the physical box and hooked it up to the internet. So SSH installed. It had SSH allow root login, which is disabled out of the box, set to yes. And the root password was PASSWORD. Like, that's why you can't let developers touch this stuff, ever. They will make it easy for them to use. I don't disagree. They're on a deadline. They want to code. They don't have time to worry about security. Security costs time in release. Always. It costs time in testing. It costs time in everything. If you want to save time, you will drop all the security stuff. That might be okay, but it almost never is, right? You can argue about security environment, security blah, blah, blah. Okay, like that's what I do, so I get it. Also, you don't know how to do that, okay? And no developer understands any of that. And not no developer, but like 10. Like, I actually mean like physically 10. Like, there are a vanishingly small number of people that understand the whole stack well enough. The whole compute stack, not the developments, because there's nothing to do with development. Right? Understanding things like how firewalls are configured and layered security access systems at the connection layer. These are not easy things. Okay, they might be easy for me. They're not easy for most people, right? And to also know programming on top of that, this is a non-trivial thing, and it's vanishingly rare. And I wish I could do it way better than I can. So, it's just not easy, right? And when you don't do it every day, it doesn't matter how good you are, right? You still have to dive back in. So if your infrastructure is totally secure and you can have your developers release into that secure infrastructure correctly, sure, maybe. But that almost never works in practice, right? Because there are all these configuration errors and exceptions because developers need to move fast. They're being told that they need to release. Release should be expensive and rare, right? And therefore perfect, right? That's the goal. Like a perfect release, nobody complains, everybody gets the features they want, and no new bugs are introduced. That would be wonderful. If you're not doing that, by the way, you have terrible software engineers. You fire all of them or some number of them until you get it right. Seriously, this is doing it the other way around is proof that they'll take anybody as a software engineer, right? Because a good software engineer doesn't want to release buggy code to the customer. Like, that's a catastrophe, right? So if you have testing in the middle, if you don't want your coders to code all the time, if you don't give them the power to make that happen, right, then you get better software. Just across the board, you have to. It's a mathematical certainty. The more time you take with it, right, the more careful you are with it, the more testing you do to it to make sure, right, regression testing, soak testing, all kinds of testing, right, lots of tests, while it's running in a production similar environment, right, then when you hit a bug, because all bugs are either coding errors, data errors, or infrastructure problems, they will be easier to find because you can narrow it down fairly quickly, right? Because you can regress you don't have to regress the code right? You can use the code from the release in your QA environment, reproduce the bug. It's not data. Good. Can't reproduce the bug. Might be data, right? Could be other things, but like there's ways to knock down to one of the three big buckets. And then once you have it in the three big buckets, it's easy to find. Oh, it's a data error. Oh, okay. We'll go find the data error in production. It doesn't exist in QA. And either move it to QA, that's a possibility, or fix it in the code in such a way that every time we hit the error, we fix it then and there. I've seen self-healing systems do that too. Those are your two options. All your other options are invalid and won't work, by the way. Unless you're absolutely sure it's due to known corruption and you can one-time fix it, which I've seen that happens. But the odds you have one-time corruption, especially on a big system with lots of hits, I got questions. I got serious questions. So I've run systems with insecure buffer overflow, known code exploits for 10 years. And they never got exploited because it couldn't get exploited because the system was properly secured. Right? And I know other people have done this. And there are very old Unix systems that have never gotten broken into because their networks are secure, basically. And so, yeah, code execution bugs don't apply if you can never execute that code. Right? So if an unauthorized user can't get to the code to execute it, the buffer overflow is irrelevant. Not ideal, but required. When you put developers in charge of the infrastructure, they'll never be able to do that, ever. This is never going to happen. And that's what you have to realize. Because the proper way to do this code is to architect it first, and then you can architect in the security. And now you don't need to have a security department. Not necessary. You're never going to have a security bug. I was not saying you don't have a security audit department. You have an audit department. They audit the security. It was also one of the failures at the cell phone company. They didn't audit the network connection or the machine. Apparently, I don't. All the machines that I had to deploy had to go through separate security and systems audits where they gave us this big long report and wouldn't let us put the machine into production or QA for that matter. Until the things were patched. And for some reason, these developers got right around that process. I'll never know how. Everybody in those two groups should be fired too, as well as the entire development team. And whatever management overrode the DevOps guys. Like, man, you had DevOps. You could have used it, and that wouldn't have happened. They were in there for a month before anybody figured it out. A month. They stole everything. Everything in the store. Yeah, pretty much destroyed the store for that company. They I don't think they ever got one up after that. So I don't know how much that project cost, but I guarantee you it was way more than 10 million bucks. When you don't do this right, there are consequences. And you might ask yourself, why aren't we doing it right? Well, we have Rant application development tools, right, which were designed to get prototypes out. You're not supposed to write a production system in Python. I'm not saying don't write a production system in Python. I write production systems in Python. That's not the point. The point is you're not supposed to, right? You're supposed to write it in a better language, like C, not C++. C++ is not a better language. Maybe Objective-C, excellent language, right? Maybe Go, right? Or Rust or something crazy. I don't like those languages, but like your mileage may vary. Like they're all built in C. I don't know what to tell you about sophistication of these languages. Some things might be easier, but you might be hiding complexity and moving it around, right? And not actually making anything easier. You're just fooling yourself about what's easier. You might be making complex threading easier at the cost of massive performance memory leaks and security problems. That's possible. Not altogether likely, we'll say, but you're moving that complexity somewhere, right? And I don't think C is ideal, right? But also, great language, and all the good stable codes in C. So all the compilers for all the fancy language you use are probably C. We're thinking about still use Python way more, right? But I also do a lot more infrastructure work where C is not good for infrastructure work. Right? Infrastructure doesn't have to be high performance. Doesn't have to be secure. Hopefully your infrastructure is already secure. If your infrastructure is not secure, securing your code is not going to help you, but whatever. You leave the door to your server room open and, with everything logged in as root, and then tell me you want to secure your network. I worked at a place that did that, by the way. And the computer room door was next to the elevator. Anyway, it had a lock on it. I don't know. It could be me. There is a way to do this, right? You have to sit down and architect. Why aren't people architecting? They want fast results. Programmers in particular with their ADHD, it's not just programmers that have that, right? They want fast results. They want a thing quickly. They want some kind of instant reward. Why? Why do they want that? I don't know, man. What else has that property? Is there another environment you can think of where you get kind of fast results and you just kind of run through it and get to the hard part and do that and feel good about it and move on to the next project or the next level in your video game? Now, I'm not saying video games are bad. Oh, no, I'm definitely saying that. I'm not saying we should get rid of all video games tomorrow, although it's not a bad idea. But also, we have way too many people brought up on video games, and in the age of Gnosis, where they think like, you can train anybody to do anything. No, good Lord, no, you cannot. You cannot. Jordan Peterson's wonderful story about a guy who couldn't be trained to stuff envelopes. Like, these people exist, right? And so if the low end is that low, what's the curve? And how hard is programming? Right? And when you have bad tools injected into the industry like Java's a horrific program. A multitude of sins. I could do 20 hours on all the problems that Java introduces. And yeah, that's what most people know. Are they programmers? I'm a little confused. Like, when you tell me you know Java, I don't even know what you know. Do you know aspect-oriented programming? Because that's nearly impossible and a stupid idea. But some people know that. I'm like, oh, okay. Oh, sure, whatever. Right? Like, I don't know what that means. Do you know OO? Some people seem not to understand OO and know Java and use the OO constructs. They just don't seem to know what they're doing. I've seen a lot of that. This stuff happens all the time. And look, maybe in your little circle of friends, everybody codes. It's all good. That's not the world. You get out there enough, you see some of these teams. I've seen teams where they've got like 2 teams, 10 people each, which is way too big for Agile. And the software they're writing, I don't know, man. Could probably bang it out in 3 hours. But you do you on your 6-month project. I've seen that. That's not uncommon. And look, hey, man, you got more people, you're employing more people, you're putting in redundancy. You don't want one superstar programmer. I agree. Like, sure, you definitely don't. But also, if someone can bang it out in an afternoon, 6 months seems a bit excessive to me. So these are the things you got to watch out for. And the video game ADHD problem it's a problem. And thinking that the solution is knowledge or training or more coursework or education or whatever is just crazy. Like, software is horrifically unstable. Every piece of software I use does strange things all the time. I'm just like, I don't know, man. And I got my Windows 7 machine over here. It's rock solid. It ain't perfect. Windows 7 has issues, but my God, the browser doesn't break as often. It stopped upgrading a long time ago, but it just doesn't randomly crash as often as the Windows 11 up-to-date browsers do. All of them. all the little utility software that I can still use on that machine. It still works great and it's super stable. And I know the bugs. They don't change every week. Goodness. I don't know, man. Like constant updates. Can't learn the software, can't document it because it's moving too fast. Like I don't, just seems like a minus.